Hello and welcome. In this lesson, we'll go over the step-by-step process to solving various types of exponential equations. Let's take a look at our first example. 5 to the power 2x minus 4 equals 5 to the power of 12 minus 2x. This is an exponential equation because the variable x is in the exponent. When solving exponential equations, we inspect the exponential terms and we examine their bases. We prefer the bases to be the same. In our case, we have a single term in each side of the equation, both in exponential form, and both of them are with base 5. So we'll say that since the two exponential numbers are equal, their powers must be the same. As you can see, now we have created a linear equation, and we'll take the x terms to one side and take negative 4 to the other. We have 4x equals 16. Divide both sides by 4. And we have 16 over 4 equals 4, which is the solution to this equation. Let's take a look at another example. 8 to the power of x equals 4 to the power 2x plus 1. We have a single exponential term in each side, but the bases are different. So then we have to think, how can we make the bases the same? We try to express each base into an exponential form with the same base for both sides. So number 8 can be written as an exponential with base 2. 2 to the power 3 equals 8, and we still have power x. Number 4 can also be expressed with a base 2. So 2 squared to the power of 2x plus 1. Apply the power law. We'll have 2 to the power 3x equals 2 to the power of 2 times 2x plus 1. Simplify. 2 to the power of 4x plus 2. Don't forget that here we're multiplying an exponent in binomial form by an exponent in monomial form, so we have to multiply each term in the binomial. And now that we have two exponential numbers equal to each other with same basis, we'll say that their exponents must be equal. So 3x equals 4x plus 2. 3x minus 4x equals 2. Negative x equals 2. Which means that x equals negative 2. X equals negative 2 is the solution to this equation. Let's take a look at another example. This time we have 4 times 32 to the power of 4x minus 9 equals 16 times 16 to the power 3x plus 5. So this equation is a bit more crowded than the previous examples. So let's take a look at each and every part of the term, or each side. We have 4 multiplying the exponential term, 32 to the power 4x minus 9. And then we have number 16 multiplying the exponential term, 16 to the power 3x plus 5. In order to simplify, we'll try to combine the terms, so multiply. Remember, when multiplying exponential numbers, the bases must be equal. And this, the number 4, is not even an exponential number or in exponential form. So we'll try. Remember that we can write any number as an exponential with the power 1 or exponent 1. So we'll give 4 a power 1 and 16 a power 1 or an exponent 1. And now we have to think, to what base do I convert numbers 4, 32, 16, and 16, to what common base? So each and every base can be converted to an exponential with base 2. So number 4 is 2 squared. Number 32 is 2 to the power 5, and then power 4x minus 9. 16 is 2 to the power of 4. And the other 16 is also 2 to the 4, and then to the power 3x plus 5. Now you're probably thinking, Well, we have the same bases in here, so we can easily combine them. So why do we have to convert to base 2? Since we are solving an exponential equation, and the variable is in both left and right side, most likely we will need the terms to interact with each other, and exponential numbers cannot combine with each other if they don't have a common base. So it's best to have the common base throughout the equation, both left and right side. So it's time for us now to apply the power law here. So we have 2 to the power of 2 times 2 to the power of. Now remember that we have an exponent in binomial form, so when you multiply, remember to expand. So that means we have 2 to the power of 20x minus 45 equals 2 to the power 4. Same thing, we have a monomial exponent multiplying an exponent of binomial form. So we have 2 to the power of 4 times 3x, 12x, 4 times 5, 20. And now it's time to take care of multiplication. So we have 2 to the power of 2 plus 20x minus 45 equals 2 to the power of 4 plus 12x plus 20. Simplify, and we have 2 to the power 20x minus 43 equals 2 to the power of 12x plus 24. Now we have an exponential number or term in each side of the equation. Bases are equal, which suggests that their powers or exponents are the same in value. So we equate the exponents, group the x terms to one side of the equation, constants to the other, and then we have 8x equals 67, from where x equals 67 divided by 8. And that would be the solution to this equation.